Suppose a body is falling in a viscous medium whose quotient of viscosity is eta. Body of radius r is falling in a viscous medium. Imagine suppose a body of radius r is falling in a viscous medium whose quotient of viscosity is eta. That's the density of the body is sigma and the density of medium is rho, and what is falling? There are three forces acting. One is the weight, and there is the buoyant force, and there is the drag force. We can write the resultant of the weight and the buoyant force as W dash, which is acting downward direction. So W dash is the effective weight, which is the resultant of weight and buoyant force. If V is the volume of this sphere, the weight is equal to sigma Vg, and buoyant force is a rho V, so it is sigma minus rho into Vg. V is the volume, and the other force is the drag force, that is the force due to viscosity. Its value when the velocity of the sphere is V is equal to 6 pi eta rv. So as a body is falling, velocity is increasing, so is Fv. So it reaches a stage. It reaches a stage when the velocity becomes terminal, velocity becomes constant. So when the velocity becomes terminal, so effective weight, that is sigma minus rho Vg, becomes equal to the drag force, that is 6 pi eta r Vt. So this is the dissipative force. Because the body is going in the downward direction, this force is acting in the upward direction. The work done by this force is negative. This negative force will evolve heat. This will produce heat. So the rate of heat production, there is a power due to this viscosity force. The magnitude of this will be Fp is equal to Fv into Vt. In the case of terminal velocity, the magnitude of Fe would be W dash, that is sigma minus rho Vg, and we can write this sigma minus V, and G is constant, so this is K into R cube, as volume is proportional to R cube. So this is KR cube, and we also know that the terminal velocity is 2 by 9 pi r square sigma minus G, sigma minus rho by eta. So terminal velocity is proportional to r power 2. This is c into r power 2. So this is proportional to r power 5. So the correct option is option 3.